This video is going to have a look at how do we identify parallel lines. So two lines are going to be parallel if they never meet when you graph them onto a Cartesian plane. So no matter how far you extend them, no matter what scale you use on your Cartesian plane, the two lines that are parallel will never meet. So to be able to identify whether two lines are parallel to each other, they've got to have the same gradient. If they don't have the same gradient, then there will be a point of intersection at some point when you graph them, and they will not be parallel. So to be parallel lines, they need to have the same gradient. So let's have a look at a couple of examples of parallel lines. So in the first example, we want to show that the following lines are parallel. And we've got y equals 3x plus 4, and we've got y equals 3x minus 2. Now, because they're in the form of y equals mx plus c, we can easily identify the gradient. The gradient of the first line is 3, and the gradient of the second line is also 3. So we know that they are going to be parallel because they've got the same gradient. So let's have a look at what they will look like on the graph. So we can graph it using the gradient intercepts method. We know the gradient is equal to 3. So that means that every time x goes up by 1, y is going to go up by 3. So we can use that to help graph our lines. So if we have a look at graphing our first line, y equals 3x plus c, we can see that the y-intercept is going to be 4. So starting at 4 on my y-axis, going over 1 and up 3, going over 1 and up 3, and then drawing a line through those points. So that is going to be my y equals 3x plus 4 line. So doing the same thing for my second line, and this time my y-intercept is going to be -2. So starting at -2, going over 1 and up 3, over 1 and up 3, and then drawing a line. And then that line is going to be 3x minus 2. So you can see from the graph that those lines are going to be parallel. No matter how far I extend those lines, they're never going to meet. So let's have a look at a second example of how do we identify parallel lines. So in this example, we want to show that AB is going to be parallel to CD, and we've got our coordinates of A, which is 2 and 5, and our coordinates of B, which is 1 and 11. Then we've got our coordinates of C, which is -8 and 6, and our coordinates of D, which is -4 and -2. Now to show that they are parallel, we need to show that they've got the same gradient. So we need to calculate the gradient of AB and the gradient of CD. So having a look at AB, that is going to be -2 and 5, and then it is going to be 1 and 11. So I want to label my coordinates x1, y1, x2, y2, and then proceed to calculate the gradient. So writing down the formula, so the gradient of AB is going to equal to y2 minus y1 over x2 minus x1. So substituting in my values that I've labeled in my coordinates, it is going to be 11 minus 5 over 1 minus -2, which equals 11 minus 5 is 6, 1 minus -2 is 3. So my gradient is equal to 6 divided by 3, which is equal to 2. So the gradient of AB is equal to 2. Now I need to do the same thing and calculate the gradient of CD. So following the same process, writing down my coordinates, so -8 and 6, -4 and -2, going ahead and labeling those coordinates, x1, y1, x2, y2. So the gradient of CD is going to equal to y2 minus y1 over x2 minus x1. So substituting in my values, -2 minus 6 over -4 minus -8. So -2 minus 6 is going to equal to -8. -4 minus -8 is going to equal to 4. So in this example, we want to show that line AB is going to be parallel to line CD. And we've been given the coordinates of point A, which is going to be -2 and 5, point B, which is 1 and 11, point C, which is -8 and 6, and D, which is going to be -4 and 14. So to show that the two lines are going to be parallel, I need to prove that they've got the same gradient. So I need to calculate the gradient of AB and calculate the gradient of CD. So starting off with AB, I'm going to write my two sets of coordinates. So -2 and 5, 1 and 11, and I'm going to label them x1, y1, x2, y2. So now I'm going to go ahead and write the formula. So the gradient of AB is equal to y2 minus y1 over x2 minus x1. So substituting in my values, it's going to be 11 minus 5 over 1 minus -2. So that is going to equal to 6 over 3. So my gradient of AB is equal to 2. So I'm going to follow the same process for line CD, starting off with writing my coordinates. So -8 and 6, -4 and 14. I'm going to label them x1, y1, x2, y2. So now I'm going to go ahead and calculate the gradient of CD, starting off by writing the formula. So y2 minus y1 over x2 minus x1, substituting in my values. So 14 minus 6 over -4 minus 8. So that is going to equal to 8 over 4, which equals to 2. So I can see that my gradient for line AB and my gradient for line CD is going to be the same. So that proves, so that shows that line AB and line CD are going to be parallel. And I can write that as gradient AB is equal to gradient CD, which is equal to 2. Therefore, line AB is parallel to line CD. And therefore I have shown, or I have proved, that those two lines are going to be parallel. So that is an example of how we can show that two lines are parallel.